Welcome to SPOTO's online quiz. Today, we'll explain real certification exam questions to help you prepare with confidence. Questions 1. A growing company wants to ensure high availability and redundancy for its critical web servers, which are located in an off-site data center. The network architect decided to implement BGP so that the network can use redundant paths for outbound traffic toward the destination subnet 10.2.2.0/24. A network engineer already configured basic BGP settings on Edge Router R1, which is a Cisco ASR 1001X router. The engineer also confirmed loopback reachability to routers R2 and R3, and the AS path length toward the destination is the same via R2 and R3. Which action must the engineer take on R1 to complete the implementation? A. Implement ASPath multipath under the BGP neighbor configuration. B. Implement maximum path SIB2 under the BGP neighbor configuration. C. Implement maximum paths 2 under the BGP global configuration. D. Implement best path ASPath multipath relax under the BGP global configuration. You have 15 seconds to answer. Answer, D. The objective is to achieve high availability by using two distinct outbound paths simultaneously. This requires enabling BGP multipath. Standard eBGP multipath, maximum paths, requires that paths be identical across multiple attributes, including the AS_path itself. In this scenario, while the AS_path lengths are the same, the paths are learned from different neighboring routers, R2 and R3, which are in different autonomous systems. Therefore, the actual sequence of AS numbers in the AS_path will differ. The best path ASPath multipath relax command modifies the best path selection criteria. It instructs BGP to consider paths as equal for multipathing as long as their AS_path lengths are the same, even if the AS numbers within the paths are different, thus allowing both routes to be installed. Questions 2. Egress PE-NAT is being used via a single centralized router to provide internet access to L3 VPN customers. Which description of the NAT operation is true? A. Users M different VRFs cannot share the same outside global IP address. B. The NAT table contains a field to identify the inside VRF of a translation. C. Multiple address pools are needed for the same L3 VPN because each site has a separate NAT. D. The different L3 VPNs using the internet access must not have IP overlaps internally. You have 15 seconds to answer. Answer, B. Egress PE-NAT via a single centralized router allows L3 VPN customers to access the internet. The NAT operation maintains a table that includes a field to identify the inside VRF of a translation. This is crucial for distinguishing between different customer VPNs that may use overlapping IP address spaces. By having this field, the NAT process can correctly associate each internal IP with its respective VRF and outside global IP address. 1. Reference, centralized egress to internet egress PE-NAT single centralized router. Questions 3. Refer to the exhibit, refer to the exhibit. In the service provider network, routers PE1, PE2, and PE4 have access to the internet and provide access to customer networks. Router PE3 is used for access to other customer systems. In accordance with the new SLA, an engineer is updating settings on this network so that router CE1 accesses the internet via PE1 instead of PE2. Which two tasks must the engineer perform to complete the process? Choose 2. A. On PE1, configure the internet VRF with import route target 102:102. B. On PE1 and P4, configure the internet VRF with import route targets 102:102 and 104:104. On P2, configure the Internet VRF with import route target 102:102. On P2 and PE3, configure the Internet VRF with import route target 101:101. On P2, configure the CE1 VRF with import route target 101:101. You have 15 seconds to answer. Answer A, E. The solution involves modifying MPLS L3 VPN route targets, RTs, to alter routing paths. RTs control the import and export of routes between different virtual routing and forwarding (VRF) instances. First, to establish the new path, the Internet VRF on PE1 must learn routes from the CE1 customer network. Configuring the Internet VRF to import RT 102:102, answer A, achieves this, assuming 102:102 is the RT exported by the CE1 VRF. This allows traffic from the Internet to be routed towards CE1 via PE1. Second, the old path through PE2 must be disabled. Configuring the CE1 VRF on PE2 to import RT 101:101, answer E, likely replaces the previous configuration that imported Internet routes. By restricting imports to a standard customer-specific RT, the CE1 VRF on PE2 no longer learns the Internet path, removing PE2 as a gateway and forcing traffic to the new PE1 path. Questions 4. An engineer working for telecommunication company with an employee ID 3715-15021 needs to secure the LAN network using a prefix list. Which best practice should the engineer follow when he implements a prefix list? An engineer must use non-sequential sequence numbers in the prefix list so that he can insert additional entries later. The final entry in a prefix list must be /32. An engineer must identify the prefix list with a number only. An engineer must include only the prefixes for which he needs to log activity. You have 15 seconds to answer. Answer A. When implementing a prefix list, it is a best practice to use non-sequential sequence numbers. This allows for the insertion of additional entries at a later time without the need to renumber the entire list, providing flexibility in managing the prefix list. Questions 5. An engineering team must implement unified MPLS to scale an MPLS network. Devices in the core layer use different IGPs, so the team decided to split the network into different areas. The team plans to keep the MPLS services as they are and introduce greater scalability. Which additional action must the engineers take to implement the unified MPLS? Redistribute the IGP prefixes from one IGP into the other routers to ensure end-to-end LSPs. Configure the ABR routers as route reflectors that redistribute IGP into BGP. Redistribute the IGP prefixes into another IGP to ensure end-to-end LSPs. Move the IGP prefixes into ISAS as the loopback prefixes of the PE routers to distribute the prefixes to other routers to create end-to-end LSPs. You have 15 seconds to answer. Answer B. Unified MPLS is a scalability solution that avoids large-scale, mutual IGP redistribution between network domains. Instead, it uses BGP as a more scalable control plane to connect these separate IGP areas, e.g., core and aggregation. The ABRs sit at the boundary and are configured as BGP speakers. They redistribute the loopback prefixes of the PE routers from their local IGP into an internal BGP, IBGP, session. Critically, these BGP advertisements carry label information, per RFC 3107, allowing LSPs to be stitched together across the domain boundaries. This creates a hierarchical LSP from end to end without merging the underlying IGPs, thus preventing instability and scaling limitations associated with a single, large routing domain. Question 6. An engineer is moving all of an organization's Cisco IOS XE BGP routers to the address family identifier format. Which command should be used to perform this upgrade quickly with the minimum service disruption? A.vrf upgrade CLI. B.bgp upgrade CLI. C.address family IPv4. D.IP BGP community new format. You have 15 seconds to answer. Answer, B. The BGP upgrade CLI command is the correct choice as it is a purpose-built, non-disruptive utility designed specifically for this migration. It automatically converts a legacy BGP configuration into the modern address family identifier, AFI, format directly on the running configuration. This process reorganizes peering and network commands into specific address family submodes, e.g., address family IPv4 unicast, which is essential for multi-protocol environments. Crucially, the command performs this conversion without resetting active BGP sessions, thus satisfying the requirement for minimum service disruption. Its automated nature ensures the upgrade is performed quickly and consistently, avoiding the risks associated with manual reconfiguration. The other options manage different configuration aspects, such as VRF definitions or community formats, not the core BGP structure. Question 7. The network operations team reported that the access site that is connected to OR3 is not connecting to the application server in the data center and that all packets that are sent from the application server to the access site are dropped. The team verified that OSPF and BGP peerings are up in BGP AS 65101 and BGP AS 65201. R4 is expected to receive traffic from the application server route via OSPF. Which action resolves this issue? A. Remove the route map on R4 when advertising 172.16.20.1 in BGP to R3. B. Advertise application server 172.16.20.1 in the OSPF routing table on R6. C. Allow 172.16.20.1 in the BGP advertisement on R3 in the route map. D. Add the next hop self command on R6 to enable R3 IBGP peering. You have 15 seconds to answer. Answer, C. The issue described involves packets being dropped when sent from the application server to the access site. Since OSPF and BGP peerings are confirmed to be operational, the problem likely lies within the route advertisement. Allowing 172.16.20.1 in the BGP advertisement on R3 by adjusting the route map will likely resolve the issue, ensuring that traffic destined for 172.16.20.1 is not being inadvertently filtered or blocked. Implementing and operating Cisco Service Provider Network Core Technologies, SPCOR, course provides insights into configuring, verifying, troubleshooting, and optimizing service provider IP network infrastructures, which includes understanding and implementing BGP routing and route maps. 1. The official Cisco certification exam overview for SPCOR, which includes topics on BGP routing and route maps, can also serve as a reference. Don't want to miss any exam content? Visit the SPOTO website now to take a free practice exam. Or add us on WhatsApp for everything you need to know.